Okay, you can begin.
Okay, so good evening, guys. I'm Peter Oweru, part of the SQL team that helped prepare this session. There are 4 members: I, Owen Muthukia, Lauren Ngaria, and Wairimu Kiarie, who is still not available but will join us in the meantime. So I hope you all have downloaded the datasets that have been sent to you. And I'll let our team leader, Owen Muthukia, to continue with it. So we'll start by creating the database, then using the datasets that we've provided. Then there are several questions which we will share during the session, which we will all use in order to facilitate the session. Thank you. Owen, you can take over.
Thank you, Peter. I believe you can all hear me. So thank you for creating time to join this session. I'll be taking you through SQL together with Lauren. This is a combined effort. Each and every person took their time to ensure that we have a very good data set that we will use. So let me share my screen. I'll showcase the data set from where we began. It will be a very short story. So we decided to use a data set that is on food supplies that were made for 2 different countries within a period of time. We used different periods. One of the periods was in 1983, 2022, and 2023. So we can be able to see the difference of how these food supplies were done during different times and seasons. So our original data set looks something like this. So we had the country code, the country, the income group, region, and the different types of foodstuffs that were given to the different countries. You can be able to see the quantities also of the different items that were issued. So after having this data set, we had to clean it up and divided it into the different tables that we are supposed to have. So we had the locations table. The locations table was to be used to identify the location of each country, the income group, and the region that these countries hailed from. Then we had the supply per country. This showed the different commodities that were given to different countries and at which period. Then we had the supplies. This showcased the product names, the SKU, and the total supply that were given within a certain period of time. So after preparing our data set, now we had to move to creating our databases. So I will move to creating the database. Just 1 minute. Share my window. Can you guys see my screen?
No.
Just a moment. Apologies for that. I was trying to restart the browser. Lauren, if you could share for me, kindly.
And what am I sharing?
Just share for me the commands that we were using to create the database. So this will work for us. So you can see this is the table that we created. We created a database called Global Food Supply, and we created the tables, the different tables. You see we have the locations table, and we have the different columns that were required for that table. Each table has a primary key. So you can see our locations table has a primary key of the country code, and it's a variable character with a limit of 255. Then we have the country name, the include group, the region. Then we have the next table, which is supplies, which has the supplies ID, the product name, the total supply, production period, and its primary key is supplies ID. And we have the final table, which is the supply per country, supplies ID, country code, product name, quantity, and production period. As you can see, our database is complete up to there. And you can see we have foreign keys on different tables. For instance, the supplies ID is a foreign key under the supplies per country, similar to country code, which makes our database unique in its own way. So, after preparing this table, we have to put the data into the different tables. That's why we separated the different tables into sheets. So for us, since we were dealing with a lot of data, we could not have to input this one by one. So we used the inbuilt MySQL feature, which is used to import from CSV. So you can see our tables. If I maximize this, You can see we have the locations, the supplies, the supply per country. If I right click on locations, I can be able to say table data import wizard. So if I select on it, I can start the process of importing data. So we will import our data into these tables. You have the locations.csv. It is very recommended to either use txt or CSV. TXT is tab delimited, whereas CSV is comma delimited. So you can see, select locations CSV, then next. Then it will prompt you to use an existing table or create a new table. We recommend highly, as you can see, the first option is the one that is selected. It's requesting us to use existing table, which is locations. You can also opt for the option of creating a new table using the data that you have. So you can proceed next. Then you will match each column to the respective column on Excel. You can see we have the source column and we have the destination column. We have the country code, which is matched to the country code, the country name to the country name, income group to the income group, and the region to the region. If I proceed on saying next, it will proceed in adding the data. As you can see, the following tasks will now be performed. Please monitor the execution, then it will complete. I will not proceed to add the...
Owen,
Yes.
it's no longer the wizard is no longer displayed. I just wanted it to...
Oh, you cannot see the wizard. Sorry. Let me start that again. This will prompt me to share my whole screen. So this is what I was trying to show you. You can see we have the table data import wizard. Just click on it. Our file path is selected. I believe you can now see the wizard import wizard window.
Yes, it's visible.
Okay, so you can now proceed to select. You can see we have the existing table and creating a new table. So we can proceed with the current table. So we have the source column, the destination column. So the country code matches to its exact column that it should. So country code matches to country code, country name to country name, the income group to the income group. So if we proceed, the following tasks will now be performed. Please monitor the execution. So the files will import. You can see it will run. It has finished the process. So 0 records imported. This is because this data is already available on the database. So we will do the same for the supplies and the supply country. And once you have completed, you can do a sample for checking if your data set contains data. So we'll just write a random query and say select from our database global food supply, and our table will say locations. We'll execute and our data will appear. You can see we have the country code, the country name, now with data, and we can be able now to go through it. Okay, this also happens to be the same for the supplies. You can see we have data for supplies for different periods and the total supply. So I'll not take much of your time. I will now start going through the questions that we have already prepared. If you have any questions, you can ask.
So, Owen,
Yes.
so you said earlier that you can import data.
Yes, you can import data.
TXT file?
Yes, you can use the most recommended one is CSV.
Okay.
So if you save your document in the CSV format under MySQL, there is that feature to import. And I believe most databases have that feature. For Postgre, you can also import, similar to also other databases.
Yeah, but I know it can be a tab separated file, but it's also like in CSV format, right? Even it's tab
Yes.
separated. Okay.
Yes, it should be in CSV format. For other databases, they also accept TXT. Yeah.
Okay.
Yes.
Thank you.
Welcome. So I will go to we will start with the questions.
John, do you have a question? Your hand is up.
I wanted to request if you could repeat the importing of the data, please.
Okay. No problem. Let me go through that again. So this is how you go about importing data. So you'll have your tables here after you've finished created. So you have the different tables, you have the locations, we have the supplies, and the supply per country table. So you will expand the tables right here. Select locations, meaning that you are trying to import data for locations. So you'll say data import wizard. Then under file path, you will select where you have stored the CSV for locations. Please ensure the CSV file is in the setup that you have created your table. In that, the columns try and match, and also the naming convention and all that is all okay. Please also don't have multiple sheets for the CSV when you're importing. So you'll select the location CSV, then say next. We will use our existing table since we already have one. If you don't have one, you can opt for create a new table, but it's recommended to use an existing table since you have the liberty to decide the different characters that you'll be using. In that, if you're using integers, variable characters, text, real, so you'll be able to manipulate all that. So we'll say next, and now we will match our source column to the destination column. The source column is what we have in Excel. The destination column is the database where we have the table. So we can see the country code matches with the country code, the country name with the country name, the income group together with it, with the next one, region and region. So you'll say next, and it will prompt you for this. So you prepare to import. As you can see, mine gives some error on duplicates. If I can show you the logs, it will not accept since all these data are available already on the database. So it will tell us 0 records imported, and we'll just say finish since we already have data. To confirm if our data is in the correct format that is required, we will use something similar to this. So we will select from global food supplies, and the table is supplies. There's a difference. This is the schema, which is the database, and this is the table where we are calling. Up to there, we are together.
Yes, thank you.
Yes, I hope this answers your question on how to import.
Yes, it does. Thank you.
Welcome. So we can now proceed. Okay. So you can see my screen, I believe so.
Not yet.
Okay. Now, okay?
Yes.
Good. So we will cover several topics today. Some of them will include data retrieval and filtering, sorting and aggregation, joins operations and data transformation, subqueries and aggregation, Windows functions and CTEs, Windows function with partition by and order by, the common table expressions, and finally we will cover view creation and usage. So you will be helping me in designing these databases, these queries, sorry. So Just 1 minute. Okay. Our first question. Let me share a link to what I will share later. So these are the different questions that we will be working on. Our database is from food supplies, and the organization issuing the items wants to analyze the income distribution in different regions. So the question that we are going to ask ourselves is, how are we going to retrieve the country names and income groups from the locations table for the Middle East region and find out how many countries in the Middle East and North Africa are low income and lower income groups. So for a case scenario, we'll just go to the data set and say we are going to select distinct from global food supply under the table locations. So if you select this, it will list all the countries. But the question of the day asks, find out how many countries in the Middle East and North Africa are low income and lower income groups. Therefore, we will be looking at the income group and the region. Okay, so we will be selecting the country name, the income group from the locations table, where the region is Middle East and North Africa. So we will say select the country name, the income group from locations where the region is Middle East and North Africa, and the income group should be equal to, we will use the feature like, so this is what we are looking for, the income group where it's like low or lower. So if we run our query, it shows us there is an error. It tells us the function global supply.income group does not exist. Therefore, we are supposed to check why the income group is not appearing. These are the some of the situations that you will find when dealing with databases. There are multiple errors that you will be finding. So let's write our query. Need to put this. Okay, you can see now there are some changes. We have only listed countries in the region Middle East and North Africa. So allow me to include the region column. You can see we have Middle East and North Africa listed in the table. This answers our question, which was requesting us to find out how many countries in the Middle East and North Africa are low income and lower income groups. Okay, we have 5 rows returned, which means we have 5 countries under the category of low. Okay, that answers our first question. I'll be sharing this set of questions that you will interact with and be able to look at them. So I'll be going to the second phase, which is sorting and aggregation. We have several questions that are in these sets.
Owen,
Yes.
sorry to interrupt. I have shared the question on the group,
Okay.
so you can follow along as Owen presents.
Thank you, Lauren, for that. So we can now proceed together. You can interact with the questions. So our sorting and aggregation question requests that the international organization is interested in the highest total supplies of each product in the year 2023. This tells us we should list the products and their total supplies in 2023 ordered by total supply in descending order. So we'll select from supplies select listings from supplies. Let me start with the schema first.
Sorry, Owen.
Yes.
Why are you calling the asterisk distinct? I thought it's all. Abi, am I mistaken something?
The asterisk stands for all. So we are calling each and every item in the supplies table. Sorry. Are we clear on that? Good.
Yes, it's just that you, when you were typing, you said select distinct, and you
Sorry,
called
sorry.
that. Okay.
It was a typo in my head. So let's say select all from global food supply schema and the supplies table. So we have the supplies ID, product name, total supply, and production period. A question is requesting us to list the products and their total supplies in 2023. So we'll select we'll select the product name. We'll now remove select all. Say select product underscore name from global supplies. We will also do a summation for the total supply. Okay, so we'll say sum total supply. We'll give this name column and call it as total supply. Let's just call it total supply. Then we will have to include the, we will know and after from we will include now the clause, the where clause, and we will say where our production period is equal to 2023. And then we will group by the product name. These are some of the features that you'll find when doing aggregation and sorting. So you'll use group by, order by. So we'll group by product name. Then order in descending order. We'll order by total supplies, total supply, in descending order. Let's run our query. Looks okay. You can see we have the product name and the total supply for the year 2023. Cereals had the highest, followed by dairy, and infant food as the least. Okay, any questions this far? Okay, silence means I can proceed. And my next question is, The organization wants to know the quantity of each product supplied in a specific country for a given period. This means we will have to join several tables together so that we can get good results and accurate ones. So we will combine data from the supplies and the supplies by country table to show the quantity of each product supplied to specific countries or a whole list of countries. And in our question, we have been requested to check the quantity supplied to Kenya during the period 2022 to 2023. So we will draft our query. We'll say select. This time we'll not be selecting all. We'll be selecting different categories. So we'll select the country code. The country code, the country name, we'll also include the income group and region. Income group, the region, from the table locations, which we will have to give it a naming convention, and we'll call it L. The reason why we are doing this is because we will be doing joins, because we need to join other tables, and one of the tables that we'll be joining is supply per country. So we'll join supply per country as our table SC. On, we need to specify how we are going to relate these two tables that contain different data, but we have similar columns. In the beginning, you remember I mentioned an issue on primary keys and foreign keys, and the foreign keys help us join the tables. This is how we are going to do it. Under locations, we have the country code, and under supply per country, we have this the country code also, which means the country code under supply per country is a foreign key. Therefore, we will proceed and say L dot country code, sorry, underscore, is equal to SC dot country code. This means we'll need to specify the first columns that we had requested to be fetched. L dot country code, L dot income group, this is L dot region. Okay. So this is a query that will fetch the country code, the country name, the income group, and the region. We also need to include the product name and the quantity. The quantity is found under the supplies table, so I will call S SC product underscore name, and we will also call SC quantity. For verification purposes and also to include the production period, we can do also a join for supplies, which we'll call S on supplies ID S dot supplies ID is also equal to SC dot supplies ID. I think we'll use the product name from the supplies table instead. Let's run our query, see what it will list for us. It has listed the country code, the country name, the income group, the region, product name, quantity. So we can specify the different where commands that we will be using. So let's say we want the country Kenya, where L dot country name is equal to Kenya, and the production period is period is equals to 2022. So we can run and you can be able to see the country Kenya received different commodities within this period, and for the year 2022 it didn't receive any infant food, and for the cereals it had 397. So you can be able to see the different items that were listed to be issued to this country. So this shows how you will join different tables and how you specify the naming convention of the tables. It's good to be able to differentiate what each table carries and what you join with. There are different types of joins. We have the inner join, the left join, the right join, the outer join, which behaves the same as left and right. You just specify left outer join, right outer join. We have all those types of joins, which we will include in our next session. So I'd like to ask, is Werimu Kiarie with us? Yes. Thank you, Kiarie, for joining us. So you can take over the session.
I am audible. I hope so.
Yes, you are.
Minute So my screen is visible.
Yes, you're visible.
Okay. So I think I'm comfortable to take you through window functions and joins and a bit of CTE. Albeit I'm not going to go too much into CTE. I'm not so good into CTE, so I'll learn as we continue. And okay, so okay, this is visible.
Yes, that's visible.
So the joins, we have 1, 2, 3, 4 joins according to W3 schools and this other guy. So let me share this. Okay, let me share this. So I've pasted in the chat. So you, okay, it's someone's portfolio website or project. I think he was doing it for fun. The guy should be called Spartan, relevant. So it's an interactive web page that you can use to learn how each join works. So like in a join, okay. So apologies. Okay, I am Brian Carey, Remo. So I should be taking you through question 4, 5, and 6. But I think before we delve into the questions, I come to the content. Okay, or should I go straight to the questions?
Just proceed. Show them the content for them to understand what we are trying to solve.
Okay. So in a join, I'll simply join. So we'll click it. So when you click, you'll see there is an effect. So in a join, it's like the intersection, that data that is common between the tables. So you'll get that. So this is our table 1 users and what they like. So user 1, Patrick, user ID. Okay, user is mapped to the user ID. The ID is mapped to the user ID on the likes table. So user ID 1, Patrick, will be mapped to claim and code. User number 2, which is Albert, is not included in here. User 3, Maria, will be mapped and so on and so forth. So when you click this, you will see that in number 2, number 5, there is no intersect of the data, and there is no common data because number 2 is not present in this table. So an inner join will return the common fields. Left join will return the data on the left table, the whole data on the left table, and if the data is not found on the right table, it will give you nulls. So that is the difference between perhaps inner. So inner you won't find any nulls, but left join you will find nulls. So, like we found Albert and Elizabeth had no entries in table 2. So, when you do a left join, you'll find Albert, since he did not have any entries in the like table, you'll get a null. Same goes to Elizabeth. Right join. So right join will get the data, the whole data on the right table, just like the name suggests. And if the data is not present in the first left table, you will get null. So when you click, you will find rugby did not have an entry. There was no entry number 6, so rugby did not have an entry, so we had null. Yeah. Outer join will simply give you it's the union of all the data. So you will get the entire set of data. I hope we are good with joins. We good? I'll assume yes. And that is the presentation on joins. So, window functions, I was trying to be playful here, but on a serious note, I like calling them just normal function with the over clause. So, like these functions should be ideally the same. Okay. Other than the first one has first and last and salary, but ideally they should be the same. But the function here has over, and when it hits this over, it indicates it's a window function. So that's why I was saying I call them normal until you add the clause over. So so here is a pictorial representation of what this is function 1, this is function 2. So function 1, it's an aggregate function. So when you do sum of the salary from the employees table, it will add down and you will get the sum down there. So when you input this function, this is what you will get. So the sum will be transferred immediately over to this place because you indicated sum of the salary. So it will aggregate 10 over. So if you are not partitioning, it will input in each cell the sum. I hope I wasn't confusing there. Then the last slide. So this is the basic syntax. This part I bet we didn't cover. So let's ignore it. Let's ignore it for now. But I'll send you this link. Okay. I'll send you this link. You can do further reading. You can go to the questions. Are we good? We are good.
Yes.
Okay. A minute. I hope my screen is visible. And on to question 5. Question 5.
Charlie, I think we're in question 4.
Oh, question 4. I'm sorry. So it reads, an NGO is interested in countries that have the highest average quantity of product supplies across all years. So basically, we want to find the highest average of supplies across all years. So it's an aggregate function. So apologies. So we want to select a country. Okay, I'm back. So we want to select a country code. That we want to ideally we want to use this table. So we want the top suppliers. Let me see the question again. So we want to select country code, from the supplier. Then we want the country name, but
Sorry about that. Kyrie has lost his power. So I think I'll just continue with the question 7 and 8. As he sorts himself out, then maybe he can join us and continue with question 4 to 6. So let me just share my screen. So for question 7 and 8, I'll be covering CTEs and creating views. So can you see my screen?
Yes.
Is my screen visible? Okay, thank you. So for the CTE, I'll just, because we had already done the queries, but I'll just explain as we read the question. So the question requires us to create a CTE named overall supplies that includes the country name, product name, and total quantity supplied. So, and then from that CTE that we've created, we're supposed to retrieve data for beef products. So basically, a CTE is a sort of like a temporary table that simplifies queries, especially when the queries are complex. And then what it does, it breaks it into manageable sections or tables. So for a CTE, when you create a CTE, it's temporary, meaning that you can only use that particular CTE that you created for that particular query. So when you close that query and maybe do another question or do another query, you cannot refer to that CTE that you created, so you need to create another CTE. So I hope that is clear. So in this case, we are meant to create a CTE called overall supplies, and then it should have the columns country name, product name, and total quantity supplied. Then after that, now we can be able to retrieve beef products from the CTE. So every CTE, of course, we all know this, it starts with a with, and then as the question has requested us to do is to name it as overall supplies. And then we have these columns in the CTE where we'll have the country name, product name, and the total quantity supplied, where we do not have this total quantity in our tables. So we have to create this column called where we are summing the quantities, all the quantities of the products, so that we can get the total quantity supplied. This is, of course, for all products. And then we are getting it from the supply per country. And we give it an alias, SC. Then now we join so that we can get the country we can get the country name from the locations table. That's why we are joining with location, since we don't have the country name in the supply per country table. So that is why we are joining with the country code, and then we are supposed to group them by country name and product name. So basically that is the CTE, but with CTE you can't just end here, because if you run this up to here, it will give you an error. So a CTE is supposed to be accompanied by a query, or rather a subquery, that now references the CTE that you have created. So in this case, based on our question, after we've created the CTE, we are supposed to retrieve data from that CTE for beef products. So that's why we have selected, we do a select, and then now we select the columns that we had created on our CTE, and you can see this is a new column that we created, that we had aggregated with some. Then from the overall supplies, which is a CTE, and then now we want to see the beef products. So let me just run this. If we run this, so we'll be able to see the beef product supplies for all years. This is an aggregation of all for 1983, 2002, 2003 for Afghanistan for the beef products. So it goes on for the rest of the countries. So up to there, is there any question about CTE?
Yes. Can you just scroll up a bit? So now for the sum of quantities that is used to create the column total quantity supplied, right?
Mm-hmm.
How is it summing? I don't know if you get what I'm saying. Is this, because it makes a total sum, it will give only one answer. So how is it summing? Is it summing as functioning like a window function, summing for supplies? Go on.
So it's summing all the quantities for all the years for each country. I don't know if that is clear. So for example, if let's say Afghanistan, in Afghanistan we have all the products that are being supplied for those 3 years. So the total quantity supplied will be summing the products for the 3 years. So that when you select a specific product, it will give you the total quantity of that specific product for all the 3 years.
So are we saying that the sum is making the sum based on the instruction by the group by, or the group by clause, rather?
Yes.
So if
for each country and for the product name, but now it is aggregating for all the 3 years for that particular country and that particular product name.
So if it was the years that was in the group by, function. That means it will sum for each particular year.
Yes.
Just trying to make that clear so that that's fine.
Yeah. So in this case, what this total quantity supplied means is that for example, Kenya, we have a specific product cereals, and then so for that particular country, Kenya, and that particular product cereals, for those 3 years that we've been given, what is the total supply of that product and country for those 3 years? So that's basically what it means. So that when now you query a particular country or a particular product, it will give you the total quantity for the 3 years. That's clear.
Yes, it is.
Okay, so we can move on to the next question, question 8, where we are required to create a view. So basically, a view is a virtual table, and this is different from CTE. So it is stored in the database under views, so you can always reference it with different queries. So it does not necessarily mean that you when you're creating the view, you query it from that particular you subquery it from that particular query that you created the view. So it simplifies the query as the CTE does, and you can use it to restrict some certain information, because now it is you to dictate what will be on the view. Yeah. So let's go to the question where it is telling us to create a view named total supplies view that includes production period and the total quantity supplied. Then from that view, we need to retrieve information for years with a total supply greater than 400,000. So we can do that. I had done the query here. So I don't know if let me just try and delete it so that you can do it again. So this is a query. Creating view, it always starts with create view. Then we have been told that the view we should name it total supplies view. Then it is followed by us. Then now we select. Now we are creating the table that we want, the table view. So we want it to have these columns, which are the production period, and then now we want the sum of quantity. Then we want it to be grouped by production period. So from the supply per country, yes, from the supply per country table. So if we run this, it has created. Then now we can refresh and see our view. Yeah. So basically, this is the table view that we've created, where it is the total quantity supplied. Now you can see here it's different because it's grouping. It's summing based on the years, the production period. So in this production period, you can see the total quantity supplied was this amount. And then in 2003, it's this amount. And then in 2022, it's this amount. So that is our view. And then from that view, we are told to retrieve information which from this view for years with a total supply greater than 400,000. So with those 3 years, we want to see which year has total supply that is greater than 400,000. So that's a very simple query which we have here, and we'll get this as our answer. So do we have any questions for creating views?
Hi.
Hi.
What I'd like to ask is, when is it ideal to use a view versus a CTE? Minus maybe when you're dealing with issues with performance and all that. So, like, when would you prefer? In what instances would you use a CTE over a view, or the other way around?
Thank you for that question. Because both CTE and creating views, their main benefit is to simplify complex queries. But now, if for the CTE, maybe you would use it if you just want to do some queries and you would not require that particular table to refer to for maybe future queries that you're going to do. So, for example, if you're solving particular problems and then you create a CTE, maybe the next few problems will not require you to use that query, that CTE. So CTE, you would use it if you are not required to refer to it maybe after a while. But if you want to maybe store a particular table that you have created, and you have a maybe you query it much later, then you might want to use the view. So for CTE, since it's temporary, you'll just use it there, and then when you're done with that problem, that is it. But for the view, if you have maybe other problems that will refer to that particular view that you had created, then I would suggest you use the view. I don't know if I've answered, or maybe anyone with another input, but that's how I've understood it.
That's okay, thank you.
Okay. So I think we are done. I don't know if Kiaria is in the meeting. Peter, is Kiaria back?
No, he's not back. So Owen will continue.
Okay.
So, Lauren,
Yes.
you can do question 6 and 7 and catch up for question 4 and 5 if you have time.
Sorry?
You can do question 6 and 7. I'll take it for question 4 and 5.
Okay. Okay, let me share my screen again. Is my screen visible?
Yes, it is.
Okay. So I'll be doing question 6. I've already done 7. Just a moment. So for question 6, it covers Windows function with partition by and order by. Kiara had taken us through this. So the question is to calculate the cumulative supplies of vegetables for each country, and then we order it by the year. So so for the Windows function, we will have the select, then we have the country code, the production and period, and the product name, quantity, and then we have the sum quantity. Then now here is where we have our Windows function, where we have been told by the question to calculate cumulative supplies of vegetables for each country. So we are partitioning by the country code because we need the country, and we are using the country code because for on the supply per country table we have the country code rather than the country name, and then we order by the production period, and then this would be our cumulative supply, of course, from the supply per country table. Then specifically we are looking at the products vegetables, and then we are going to order it by the country code, and then by also the production period. Yeah, as the question is saying, we are ordering it by the year and the country code. Yeah. So let's just try and run this. So we can see that it has been partitioned by the country code and the production period, and then we want it to be ordered by the country code and the production period. I don't know if I'm making any sense. Am I clear on what I'm saying? I guess silence means everyone has understood.
Please just say that again.
I repeat the whole thing.
That last portion.
This order by.
Yes.
Yeah, so based on the question, it's requiring us to order by the country and the year of production. So
Is that question 6?
Yeah.
Okay, we can go on.
Hello.
And see we yes.
Yeah. Please finish first, then I'll ask.
Yes, so you can see the cumulative supplies for example, for this country code. For the year 1983, it was 56.3. Then when you go to the next year, it would be 247. That is this figure plus the first year, which is 1983. Then for the last year, you basically add it, then it would give you this value. So any questions?
Okay, let's go to the quantity section. Can you just explain that line of code and why you use partition by, over, and all those parts?
Yeah, here.
Yes.
Okay. So we are trying to, let me just go back to the question. We are trying to calculate the cumulative supplies of vegetables for each country. Then we order them by their year. So we are supposed to partition this based on the country. As you can see, so for example, this is one distinct country with this country code. So that is it's being partitioned by country and by the year. So you can see for this particular country, ordered by this particular in this particular year, we have this quantity, and the cumulative by at the end of this year, it's this. Then this the second year, you have the 2022, which the quantity is 189, and then the cumulative now is this for the first year, that is 1983, plus this 189. So you get this. So basically, this is the partition by that is happening here. So it has partitioned by the country code, and then ordered by the production period. I don't know if that's it.
Why should I use a partition by instead of a group by?
Where, group by where? Here.
I'm asking, yes, now why do I use a partition by if I instead of a group by? What advantages what does it do differently?
So how would that group by, let's just do it and see how would the group by look like. So we are here.
Yes.
So,
So
instead of doing all this, or
no, leave the sum. Leave the sum. Remove the over. Yes. No, leave some as leave the alias. Leave the alias. Just remove the partition.
As the alias was what? Cumulative
supplies.
supplies.
From yes, where okay. Then after the vegetables, we do group by
Group
I think country code, right?
here. Country code.
Yeah, I think that's just then country code, then also production period.
Sorry?
Group by country code and production period.
And production period.
That's it.
Like that.
Is it and that is supposed to be there or comma? I'm not sure.
Okay. Okay. Yeah, there's an error. So I'm not sure about this.
Non-aggregated column.
Excuse, you cannot group by two conditions. I think you should remove one.
Okay, let's just try with this. Still. I'm not sure why.
Lorraine, what are we looking for?
There's a question, or
Yes.
question 6, yeah? They're asking why can't we just use group by instead of using this Windows function? So that's what we are trying to do and see if it's possible. But now the question is, why is it not possible to use group by?
Okay. So the way we had structured the question first was by utilizing the Windows functions. But if you want us to utilize the group by, we can do it also. Let me draft that query real quick.
I think the idea was to try and figure out when to use the Windows function, the partition
Yes.
by, and when to use the group by so that it's clear to all of us when it's ideal.
Okay, let me do that shortly.
Yeah, and also to find out if this particular question can also be solved by using the group by.
Can you hover your mouse around the error so that I can just read the error and see? No. Okay. Expressions. So expressions.
Lorraine, try and remove the order by the first order by country code. Remove country code. Try and run it.
No, it's still doing the same thing. It's still doing the same thing. Please, can you just put it again? I'm still reading the error code to see whether I can figure it out. Select list.
Lauren, can I ask a question?
Yes.
Are the column names case sensitive because the country code in group by and in the select the country
I don't think so. It's not.
No, it's not. It's not case sensitive in SQL.
It's not.
Thank you.
Can we just see the table? Can you just let us see the table? Maybe just let us see how the table looks.
The supply per country table.
Yes, the supply per country table. Yeah. So country code appears a number of times. Product name, age. Okay, it's fine. We can now look at the code again.
Um, I believe you guys can see my screen now.
Let me stop sharing. Is it? Oh, okay. Yeah.
Yes. So this is a query that you are asking for using group by clause. We are going to select the country code, the production period. We are going to sum the quantity as the cumulative supplies from the supply per country table, where the product name is equals to vegetables, and the group by clause is we have country code in the production period. Then we are going to order by production period. So this is the outcome.
So why did it run in Lorenzo?
Yeah, because we had the same.
Yes, you find there's some differences, especially on how you're placing the group by. So in the query, the quantity includes sum, which is an aggregate function in the clause, which is making it consistent.
Has also has that.
Yes. So when you use the select clause, and you're using these formulas, especially the aggregation, the sum, quantity, and all that, so you find at times it might not be able to put it all together, since we are grouping also by the, what do you call it? We're also grouping with the product name. So that's the difference that I've put in mind, where we're going to include also the product name.
Oh, you remove the product name from the select.
Yes. Yes.
Owen.
That's what I did. Yes.
I have the product name, but what I've done, and it has worked, I've removed the quantity, because we had quantity, then now we sum quantity. So I've removed the quantity and it has worked.
Okay. So that's another thing. So personally, I removed the product name and avoided grouping with it, so that we can be able to have a cumulative value. I believe that has answered the question of the difference of using the Windows function.
Excuse, Owen,
yes.
could you please scroll down on this table, the table that you've generated?
Yes. Okay.
So it has grouped by the product period, right?
It has grouped by the production period and the country code.
So I think there's a difference between the petition by and the group by, because here you see the petition by had petitioned the country code. They were in a sequence. I think it was bringing the country code for and the year at the same time. Each country for the 3 years, and then it goes to the next country based on the country code.
Okay, we can do that by, if we could say, order by country code.
But I think that has answered Ray's questions. I think, Ray, you've seen the difference between the Windows and this one.
Yes.
So the one that you were saying, grouping 3 countries, the period is what? Yes, you order by country code, yeah.
Order by country code, okay.
Yes. So you'll have the countries in each year. So you have the 1983, 2022, 2023. Then it moves to the next country.
So the question would be, when then is it ideal? Because I feel like right now when we have done this, we have achieved the same results as the Windows function. So
Yes.
when then is it ideal to use Ether? Or can they be used interchangeably? Because I know, yes, partition by works with like chunks. So it solves, it works on one chunk and then on the other chunk, like that, and like group by. But then we have been able to achieve the same results. So when then do we use partition by against like instead of group by?
So I was thinking in my head while I was asking that question, because when I looked at this question, I saw that it's possible to achieve it by group by. So, however, I think the partition by will be appropriate, when you want to find running sums. What that literally means is that you want to find sums that are not, for instance, in a department. Let's say, let me look at this table. Okay, for instance, if there's a department now that has rice, beans, yam, and so on, and let's say that department has rice, beans, yam, want to find out maybe it has maybe multiple rice, then multiple beans, and so on. We now want to find out the sum of the rice within that department, right? Without doing the total sum of getting maybe, how should I put it? Okay, let me say it in simpler terms. If we have 4 departments and we want to find out the sum within a department, within that department, then that partition by would work for us, because group by would only pick, the entire department and do the sum. But if it's within the department, I think I can use the partition by and get the results we're looking for.
Actually, when using Windows functions, when doing aggregations, you find if you are doing a small set of aggregation, you can use the Windows function partition by. But when you're using, let's say you're using different summations within the same query, it is recommended that you use group by. I don't know if I'm communicating. What I'm trying to mean in our query here, the first thing the reason why we used the partition by, it's because we wanted to show how partition by works from the Windows function perspective. But if we had more than one summation, let's say we did a sum for the quantity, we did a sum for, let's say, vegetables, cereals, and all that separately, and we wanted the figures, then we could have used group by. This means group by has the capacity to carry a wider load of summations compared to the Windows functions. And when you're grouping, you find you need distinct figures for each column. So you might find group by will work more better compared to partition by. So that those are some of the differences that you might find. Is that okay?
Yes.
Okay. So I will continue to. You have been shown how to work with CTEs and creating views. I'll take you through to subqueries. For the subqueries, the NGO is interested in countries that have the highest average quantity of product supplies across all years. And we have been requested to find the top 3 countries with the highest average quantity of supplies across all products and years. So let me create a query for that as we continue here. Actually, I'll just use, to save on time, I'll just use one of the queries that we had already prepared. So we have been asked to identify countries with a low income group that had a total quantity. This is the question? No, this is the question. Top 3 countries, yeah. Top 3 countries with the highest average quantity supplies across all the years. So we are going to select the country code and the country name from the table's supply per country, where we will do joins with the locations table. Then we will group by the country code and the country name, and we have this formula here for the average of the quantity as average quantity. Then we will order by average quantity in descending order, and we will use the limiter to 3. So if we run our query, we get these 3 countries, which is Pakistan, South Africa, and Nigeria, whereby Pakistan has an average quantity of 264, followed by South Africa, which has 240. Then we have Nigeria at 218. Let's try and break down our query. Our query is, as you look at it, doesn't have a lot of functions with it, but basically we are able to have what do we call it? We will create a subquery from whatever data that we will be fetching here. So as we go to the next one, you'll see the next question prompts us from whatever data we have found. Let me read this question. Basically, this has this part of this query has taken a view on aggregation, so it shows aggregation. Then we'll move to the next question, which prompts us for the rank on countries based on the total sum of quantity of poultry and show only the top 3. So we'll use with ranked countries as we'll select from the query, from this query, select the country code, the country name, the quantity, rank over order by sum of the quantity in descending order as quantity rank from supply per country. This is our table. We join the supplies, and we join also the table locations where the product is poultry. Then we'll group by the country code and the country name. In it, we have the subquery where it will tell us the country code, the country name, sum quantity from the subquery, the ranked countries, where quantity rank, we limit it to 3, which is equal to or less than 3. Let's run our query. I'll just run it here. Okay, just 1 minute. Enter this first. Yes, so you can see it has listed the countries, the country code, the country name, the sum and the sum quantity that we needed. in our query, you can see we have used a CTE that is the ranked countries that has helped us to calculate the sum of poultry supplies for each country and assign a rank based on the descending order of the summation. We have also done the joins in it, and we have included the Windows function of the rank. And also we have included this is the CTE, the ranked queries, the ranked countries. Sorry, these are the joins for us to get the 3 countries with the highest, with the top ranking on poultry supplies that were done by this organization. Any questions? Any questions? Those are the 2 remaining parts, which was subqueries and aggregation, and the Windows functions, ranking and CTEs. You had been taken through CTEs by Lorraine. That was just a glimpse of the remaining part. I believe with that we have covered the 8 topics that we had planned for in this session. Your feedback is very valuable to us. So if you notice we missed something, you can reach out to us. You can also reach out to Nehemiah or Eve. I know there will come a documentation requesting for your feedback from Eve, and maybe some of the places that we have missed. In our next session, probably, if we get a chance to have one, we will work on a pipeline. So you can plan for that. Yes, John, I will share the workbench. I don't know if that's possible, but I'll try. So that's all from us. Have a nice evening.
Thank you.
Yes, Nehemiah, thank you for the platform.
Have a good night, guys.
Good night.